Yeah, welcome. So we are discussing about minimum cost spanning tree. So the topic we'll be discussing in this lecture is Solin's algorithm. So in the last class we have discussed about Prim's algorithm, and before that we have discussed Kruskal's algorithm. So this session we'll be discussing about Solin's algorithm. Okay, fine. So coming to Solin's algorithm. Yeah. So this the way of working of this algorithm is little different from other algorithms whatever we have discussed. Uh, so this is the graph. The graph we are taking is the same graph for which for this particular graph we want to identify the spanning tree, right? So initially we take this graph without any edges as usual. Okay, but now each one of these node we consider it as a component. Say this is one component, this is another component, this is another component, this is another component, this is another component, this is like that. Every node is one component. Now all these components were disconnected. All these components were disconnected. Totally there are 7 vertices. Each of these 7 vertices were disconnected. The algorithm how it works in the sense we will be keep adding edges based on some condition that we will be discussing. Then after each iteration it will check like how many uh, components are there. So if you see here there are 7 components are there. So in the next iteration it will check how many components are there. Say it becomes 5. Then in the next iteration it will check how many components are there. Say I'm assuming, right? Say it becomes 3. Say in the next iteration it will see how many components are there. It will say it becomes 1. Then it will stop. So the condition for the algorithm to stop is when there is only one component, the algorithm will stop. As long as there is more than one component, the algorithm will be keep continuing. Okay. So so this is the whole overall logic, but exactly how it works we will discuss. So this particular table it shows the different vertex and the edges arising from each vertex. So from vertex 0 if you see there are two edges. One is to 5 and another is to 28. This edge cost is 10 and this edge cost is 28. So that's what mentioned here. The edge from 0 to 5 the cost is 10 or the weight is 10. The edge from 0 to 1 the weight is 28. Similarly for all vertex it is mentioned. For vertex 1, from vertex 1 if you see there are 3 edges. There is edge to 6, there is edge to 2 from 1 and there is edge to 0 from 1 with a cost of 14, 16 and 28 respectively. So to the edge 6 the cost is 14, 1 to 6, 1 to 2 the cost is 16, 1 to 0 the cost is 28. So on and so forth for all the vertex we are just this table just shows what are the edges connected with those vertices and what are those and what is their weight. Okay. So initially we have these 7 components. Now what should we do in the sense we have to take every vertex. We have to take every vertex and for each vertex we have to identify the minimum edge connected with that vertex. So if you see vertex 0, the minimum edge connected with vertex 0 is this edge 0 to 5 because there are two edges. One is 0 to 5, another one is 0 to 1. The minimum cost edge is the one which goes from 0 to 5. So that edge we will just mark it down. We won't add to the graph. Like that we have to identify for all the vertex we have to identify the minimum edge. Then we will be adding to the spanning tree. Okay. So we have identified for 0th vertex. Now we will identify for the first vertex. First vertex, which is the minimum edge, there are three edges, one with cost 14, one with 16, one with 28. So the 14 one is the minimum cost edge. So that is from vertex 1 to vertex 6 with a cost of 14. Similarly, identify for vertex 2. So only one minimum cost we have to identify for each vertex. One minimum cost edge we have to identify. From 2 there are two edges, 2 to 3 with a cost of 12, 2 to 1 with a cost of 16, 2 to 3 12, 2 to 1 16. So the minimum one is the one from 2 to 3 with a cost of 12. Then we will identify for vertex 3. Vertex 3 there are three edges, with one with a cost of 12, another with a cost of 18, another with a cost of 22. So again the minimum one is 3 to 12. 3 to 12. Okay, right. Similarly, identify for vertex 4. From vertex 4, how many edges are there? 1, 2, 3. 3 edges are there. The cost are 22, 24 and 25. The minimum cost is from 4 to 3, which is of a cost of 22. Okay, the cost is 22. 4 to 3, the cost is 22. And from vertex 5, there are two edges, one from 5 to 0 and another from 5 to 4. So the one which goes from 5 to 0, that is the minimum cost edge. Okay, fine. Now from vertex 6, what are the edges? There are three edges. One edge goes to 1, 6 to 1, another 6 to 3, another 6 to 4. So 6 to 3, 6 to 4 and 6 to 1. The minimum one is which goes from 6 to 1. So that is with a cost of 14. So these are the edges we have identified for each vertex. So now we will add these edges to the spanning tree. So for vertex 0, what we identified? 0 to 5. So just add this edge. Next for vertex 1, what is the edge we have identified? 1 to 6. So add this edge, 1 to 6. Now for vertex 2, what is the edge we have identified? 2 to 3. 2 to 3, so add this edge, 2 to 3. Now for vertex 3, what is the edge we have identified? 3 to 2. Vertex 3, what we have identified is 3 to 2, which is same as 2 to 3. 3 to 2 is nothing but 2 to 3, because it is a undirected graph. Okay, so we have already added. Okay, so we can ignore this because it is already added, right? Fine. Then from vertex 4, the minimum cost edge is 4 to 3 with a cost of 22. So 4 to 3 with a cost of 22. Okay. Then from vertex 5, what is the minimum cost edge? 5 to 0 with a cost of 10. That is already added. 0 to 5 is nothing but 5 to 0. So we can also ignore this. Okay. Similarly, from vertex 6, there is a edge from vertex 6 to 1 with a cost of 14. That is also already added. 1 to 6 is already added. 1 to 6 is nothing but 6 to 1. So we will ignore this also. Okay. So this is the end of first iteration. This is the end of first iteration. So these are the weights. 0 to 5 is 10. 1 to 6 is 14. 2 to 3 is 12. 3 to 4 is 22. Okay, fine. Now you see the graph contains how many components? Previously there are 7 components. Now the graph contains only 3 components. This is one component. 0 to 5 is one component. 1 to 6 is 1 to 6 or 6 to 1 you call, this is another component. This 2, 3, 4 or 4, 3, 2 is another component. Now we have 3 components. Originally we had 7 components. After first iteration, 7 components has become 3 components. So how long the algorithm will continue? Until there is only one component, the algorithm should continue. Okay. So each of these components were disconnected. So component means these are disconnected components. That is, so that we call it as component. So see, for example, this component, it is connected, but it is connected from 0 to 5 and 5 to 0. That's all. It is not connected with other components. Similarly, 1 to 6 is connected from 1 to 6 and 6 to 1. There is no way to reach from 1 to 0 or 6 to 0 or 1 to 5 or 6 to 5. Okay. So this is one separate component. 2 3 4 is another component. Among 2 3 4 they are connected. You can go from 2 to 3, 3 to 4, or 4 to 3, 3 to 2, or 3 to 4, or 3 to 2, anywhere. But you cannot move from 2 to 6, or 2 to 1, or 3 to 6, or 3 to 1, or 4 to 6, or 4 to 1, or 2 to 5, or 2 to 0, anything, right? So each of these are connected, but they are separate components. Okay, fine. The next step what we have to do is, so this is, now we have three components. So I will use a different color. Now we have three components. This is one component. Okay, this is another component. This is another component. From each of this component we have to identify one minimum edge. In the previous round also we did the same thing only. In the previous round there are 7 components. So in all the 7 components we identified a minimum edge. Now from each of this component we have to identify minimum edge. So this component contains how many edges? In the previous round there are 7 components. Each component includes only one edge. But now each component may have more than one edge. So if you see this component, it has how many edges? It has 2 edges. Okay, I mean 2 vertices. In the previous case each component has only one vertex. Here each component may have more than one vertex. So the first component has how many vertex? It has 2 vertices. So we have to see what are the edges which are going from 0, and from what are the edges which are going in these 2 vertices from 0 and from 5, and which is not added to the spanning tree yet. Out of that we have to identify the minimum edge. Okay, so so for this particular component there are only 2 vertices, 0 and 5. So first let us see for 0, how many vertices are going from 0 and that is not added to the spanning tree. So if you see, this edge is not added to the spanning tree and its cost is 28. This is added, so we cannot consider. So there are only 2 edges. This is the only edge which is not added. Okay, so 0 side is done. Now we have to similarly check 5. For 5 also there are only 2 edges. 5 to 0 is already added. There is only one option. Now we have 5 to 4. Okay, so there is only 2 edges connected with this component which is not yet added to the tree. So what are they? One is from 0 to 1, another one is from 5 to 4. Out of this identify the minimum cost edge. The minimum cost edge is what? 5 to 4. 5 to 4. Okay, so just mark down this. The minimum cost edge is what? 5 to 4 with a cost of 25. Because the cost of other edge is what? The cost of other edge is 28. Okay, so we will just note down this. Will not add, at last only will add. Okay, after identifying for all components only will add. So just mark down 5 to 4. This edge we need to add for the first component. So now we have done for the first component. Similarly do for the second component. Second component contains how many vertices? 2 vertices. What are they? 1 and 6. Identify all the vertices which are going from 1 and which is not yet added to the tree. So 1 to 6 is added. Okay, 1 to 0 is not yet added. So this is one edge we have, 1 to 0 with a cost of 28, and then we have 1 to 2 with a cost of 16. We have 1 to 2 with a cost of 16. So this also we have one option we can add, but we have to consider other vertex, other vertex 6 also we should consider. So from 1 we have 2 edges. One is from 1 to 0, another one is from 1 to 2. Now let us see from 6. From 6 you have a vertex, we have an edge from 6 to 3 with a cost of 18, and you have an edge from 6 to 4 with a cost of 24, and you have an edge from 6 to 1 with a cost of 14. So totally if you see there are 5 edges. Okay, let us delete other edges which are not required here. So this is previous case. Okay, so from the number of edges which are connected to this component, is and which is not yet added, how many, this is added, right? This is added, so don't consider this. Okay, so the number of edges which is not yet added, the number of edges which is not yet added and which is connected with this particular component 1 to 6 is four edges, 1 2 3 4. So one this edge cost is 28, this edge cost is 16, this is 24, this is 18. So pick up the minimum cost edge, this is 16. Okay, so 1 to 2, so this edge we should consider 1 to 2. Okay, so now we have done for the second component. Similarly we have to do for the third component also. Similarly we have to do this same task for the third component. Now if you see third component, it contains how many vertices? It includes 3 vertices. So for all the 3 vertices we have to check the edges which were not yet added to the tree, and among that we have to identify the minimum cost edge. So starting from 2, if you see, so 2, there is edge 2 to 1 which is not yet added, its cost is 16. 2 to 3 is already added, so there are only 2 edges, 2 to 1 and 2 to 3. 2 to 1 is not added, this is the only option we have. Coming to 3, 3 to 2 is already added, so leave it. 3 to 6, 3 to 6 the cost is 18. 3 to 4 the cost is, 3 to 4 is already added, so there is no point in checking that, so we will leave that 3 to 4. Okay, so starting from 3 we have 3 edges actually, but 2 were already added. 3 to 2 is already added, 3 to 4 is also already added, so we have only one option which is 3 to 6. And coming to fourth vertex, 4 to, we have 3 edges, 4 to 5, 4 to 6 and 4 to 2. 4 to 3, 4 to 5, 4 to 6 and 4 to 3. 4 to 3 is already added, so we will ignore that. 4 to 6 we can consider its cost is 25. 4 to 5 also can be considered, its cost is 25. 4 to 6 cost is 24, 4 to 5 cost is 25. So these are the 4 edges we have, 1 2 3 4. Out of that we have to pick the minimum cost edge. What is the minimum cost edge? 2 to 1. So note down 2 to 1. Okay, so now we have checked all the components, and for every component we have identified a minimum edge which is not yet added to the tree. Okay, now we will add these edges. Okay, so after checking fully only we should add. It's not that after identifying for one component we will add. No, not that way. Okay, that is important, because otherwise it won't work properly. Okay, fine. So now we will add these edges. First, which edge we will add? 5 to 4. So 5 to 4 you just add 5 to 4. What is the cost? 25. Okay, next you add 1 to 2. What is the cost of 1 to 2? 16. Next you see what is that? 2 to 1. 2 to 1 is nothing but 1 to 2. It's already added, so leave it. Okay, this is the reason why we are adding at last. Okay, if you are adding in between, then it will create it will not work properly. Then you will already add 1 to 2, then you should ignore that. All those things will come. Okay, so now the second iteration is over. Okay, after second iteration, now you check the graph. How many components are there now in the graph? I mean in the tree, not the graph, spanning tree. Now how many components are there? Now we have only one component. Okay, and this is a connected component. From 0 you can move to any vertex, from 1 you can move to any vertex, from 6 you can move to any vertex, from any vertex you can move to any other vertex. So initially when we started there was 7 components. In the next round, at the end of first round it becomes 3 components. At the end of the second round it becomes only 1 component. Okay, so when it becomes 1 component you have to stop. So now we can stop the process. Okay, right? So that's it about Solin's algorithm. Okay, so that's it about our discussion in graphs also. So with this we'll put a full stop for the topic graphs. Okay, so from the next class onwards we'll be moving to the next topic, which is about searching and sorting techniques. Okay, thank you.